Module 6, problem number 3. For the accompanying data set, A, draw a scatter diagram of the data, B, compute the correlation coefficient, and C, determine whether there is a linear relationship between X and Y. Part A, draw a scatter diagram of the data. Choose the correct graph below. So let's... Module 6, problem number 3. For the accompanying data set, A, draw a scatter diagram of the data, B, compute the correlation coefficient, and C, determine whether there is a linear relation between X and Y. Part A, draw a scatter diagram of the data. Choose the correct graph below. All right, to do this, we're going to first click to open the data set. Then we're going to click on the icon right here to open that data set in Statcrunch. All right, so we're going to go to Graph, Scatterplot. They kindly named them X and Y, so just select your X and Y variables and click Compute. And you can see it's closed out here. We have a scatter plot here and 4 options. So as we see here, we have 3 dots and a little line down here and then 2 up here. That appears to match up with these 3 dots here and 2 here. You can also do this by manually checking the data points, but it's good to practice generating the scatter plot in Statcrunch. That's option C. As you see here, all the other ones have a different pattern and different data points. Check answer, fantastic. All right, B, compute the correlation coefficient. As I mentioned in my lesson this week, it's really tedious to do this by hand. I highly recommend just going to Statcrunch. It's super easy and it'll save you headache and time. I'm going to show you how to do it in Statcrunch. We're going to go to Stat, Regression, Simple Linear. This is just linear regression. X is your X variable, Y is your Y variable. Click Compute. And you see here, this brings up a bunch of results. You have your equation right here, y equals 5.5 minus 0.08333x, and your r coefficient. You also have your r squared. So our correlation coefficient, as you see there, is negative 0.091. So let's put that in. We're rounding to the 3 decimal places, negative 0.091. Check answer. Excellent. All right, part C, because the correlation coefficient is blank, well, it's negative, and the absolute value of the correlation coefficient blank, so that absolute value is just the absolute value of this, is going to be 0.091, is blank, then the critical value of this data set, blank, blank. So the next step we need to do is look at our critical value. Remember, the critical value depends on the data size. We can tell right here our n equals 5. We can also open up the data set and see we have 1, 2, 3, 4, 5 data points. So now let's go to our critical value table, go down to n equals 5. So our critical value is 0.878. I'm just going to copy that, go right down here, and I'm going to put it in there for that critical value. So that 0.091 is less than that 0.878. So we're going to say that it's not greater than the critical value for this data set. So no linear relation exists. When the absolute value of the correlation coefficient, so the absolute value of R, is less than that critical value or not greater than that critical value, then there's no linear relation. It's saying it's just not there. So we're going to say no. So let's read that sentence again just to make sure it's really clear. Because the correlation coefficient is negative and the absolute value of the correlation coefficient 0.091 is not greater than the critical value for this data set 0.878, no linear relation exists between X and Y. Let's check answer. Excellent. So that's how you do problem number 3. If you have any questions, let me know.